All right, we got trig identities today. Trig identities need to settle in. It's going to be fun. All right, here they are. The fundamental, it says fundamental at the top, fundamental trig identities. Most of these you know already, and we're going to use them to create some more. I know that sounds awesome to you, and it really is. So here we go. Reciprocals, I've tried to drill these in your head since day one we started trig. Don't forget these two, tangent, sine over cosine, which means cotangent is cosine over sine. We've seen the Pythagoreans before, these in the middle. Pythagorean sine squared plus cosine squared. Gosh, sine squared plus cosine squared is 1. That's the most famous one. Tangent squared plus 1 is secant squared. Actually, if you change this to sines and cosines, you would end up right back there. Same thing on this one. 1 plus cotangent squared is cosecant squared. The co's go together. If you changed all these cotangents and cosecants to cosine and sine, you would end up right back there. So these two Pythagoreans come from the original one. Sine squared plus cosine squared is 1. All right, you've seen the even odd identities before. Basically says this: if you have sine of a negative angle, you can take the negative sign and stick in the front like that. The cool one is cosine because it's even. Cosine of a negative, you can just like drop the negative completely. Tangent negative, same as sine, it goes in the front. So those sets, very familiar with, no big deal. The last one, cofunctions, may be a little bit newer and a little stranger, but I want to show you something. What this is saying is sine power 2 minus an angle is the same thing as cosine. Cosine power 2 minus an angle is sine. Tangent power 2 minus an angle is cotangent. Cotangent power 2 is tangent. Secant, cosecant, go do the same thing. Remember, power 2, same thing as 90 degrees. So I want to take you way back to the 30, 60, 90. Here's 30, here's 60, there's 90. And then sides went like this: 1, square root of 3, and 2. All right, now, think about doing, first of all, 30 and 60 add up to be 90 degrees. That's the same thing as power 2. Okay, so watch what I'm going to do here. If I think about, let's say the sine of 30. If I do sine of 30, it is opposite over hypotenuse, which would be 1/2. That's cosine of 30. Now, think about what sine of 60 is. Sine of 60. Sine of 60, you would do adjacent, which is 1, over hypotenuse, which is half. So cosine of 30 is the same thing as cosine of 60. And the reason is because they add up to be 90. That's what these say. If two angles add up to be 90, and one's sine and one's cosine, they have the same value. If one's tangent, one's cotangent, they have the same value. If one's secant, one's cosecant, they have the same value. So the power 2 minus x, or minus u as it's written here, really means 90 minus that angle. So if I have sine of 30, that's the same thing as cosine of 90 minus 30, which is 60. Okay, same thing. Power 3 and power 6 add up to be power 2, which is what's in these identities. So that means the sine of power 3, the sine of power 3 equals the cosine of power 6, because they add up to be 90. That's what these say. So anytime you see, I'm making a mess here. Anytime you see like a cosine of power 2 minus x or u or whatever, you can replace it with a sine. If you see tangent power 2 minus u, you can replace it with cotangent. If you see secant power 2 minus u, you can replace it with cosecant. Okay, so that's how those work. Spent the most time on those because I feel like those are the ones used the least, and you just haven't seen a whole lot of them. Okay, the rest of today is going to be examples. Let me show you this. Okay, the first thing I'm going to have you do is simplify. Using those identities to simplify expressions. Okay, so one great strategy when you're simplifying and even doing identities is to change everything to sines and cosines. So I'm going to take that tangent, t, and change it to sine t over cosine t, and then I have sine t right there. I don't know why that keeps moving. Sorry about that. Okay, and those are all t's, by the way. So if I start working this thing out, I have cosine t plus, if I multiply these two, it gives me sine squared t over cosine t. All right, now, I have to add those together. So I'm going to make one big fraction. My LCD is cosine t. This is really cosine over 1. It needs the cosine, so I'm going to multiply the top by cosine. That gives me cosine squared plus sine squared in my numerator. Are you kidding me? Cosine squared plus sine squared, we know what that is. That's 1 over cosine t. And what does 1 over cosine t equal? What's reciprocal of cosine? Secant t. So we took that big expression that we started with right there, simplified it down just to secant t, using the identities we had. How fun was that? Let's try another one here. If they're fractions already, same deal. I'm going to add the two fractions, make one big fraction. My denominator is cosine. I'm going to change them to x. It's cosine x and 1 plus sine x. That's my denominator. Okay, now, when you add two fractions together, here's a secret for you. Nobody's probably ever told you this before. But what you do is, okay, I've told you this. What does this one need that is down there? It needs the 1 plus sine x. So really what I'm going to do is I'm going to cross multiply right here. So it's going to give me sine x times 1, which is sine x, plus sine times sine, which is sine squared. I'm going to do the same thing here. This denominator needs the cosine. So I'm going to multiply cosine times the top, which is cosine squared. All right, here's what I'm seeing. In my numerator, right there, I see a sine squared plus cosine squared. Guys, that's 1. Get used to seeing that a lot. Cosine x on the bottom, I still have this. And one thing I'm noticing here is on the bottom, I have a 1 plus sine x. And in my numerator, I have a 1 sine x plus 1, which is the same thing. So those cancel. What that leaves me with is 1 over cosine x. And we just saw this a second ago. 1 over cosine x, secant x. Simplified that big monster of two fractions down to just secant x. So the first thing you're doing in class tomorrow is we're going to use all these identities, and we're going to give you an expression, and you're going to make it as simple as you possibly can. Man, that's fun. All right. Next thing we're going to do is we're going to prove identities are correct using those identities. So we're going to use identities that we know are true, which is on the first slide. Those are all true to prove things we're not sure are true or not. Here's the strategy. Number one, start with one side. We're going to try to just pick one side and break it down and make it look just like the other side. If we can make one side look like the other side, it's true. Number two, use the one we know. Use the first slide on this video, all those identities I showed you, use those. It also says use algebra. A good thing to do, number three, change things to sines and cosines. We're just more used to working with sines and cosine. If you're stuck, do that. Number four, my advice, the Brown rule, don't sit and stare. Do something. You can sit and stare. I'll be honest with you. When I start these things, a lot of times I don't know where I'm going with it. I start it, and then as I get going, I kind of see where I'm going, and it becomes easy. Okay, so you got to do something. Use some identity. Pick out some identity and go. Let's try. I'm going to show you two, and we'll start the video. And here we go. First one. Consider this equation. Cosine theta times secant minus cosine theta is sine squared, and verify algebraically. That's what we're doing all day, verify algebraically. I wanted to show you the directions one time, but those are going to be the directions. So what you do is we're going to take I'll say the tougher side. I'm going to take that side right there and see if I can make that equal sine squared. That's the goal at first. So what I'm going to do first of all is I'm going to change things to cosines and sines, and everything is cosines except for the secant. Secant is really 1 over cosine. I should have used x again. This theta on this iPad is hard to do. Okay. Now that I changed it, I'm just going to do my distributive property. If I do cosine times its reciprocal, you just get 1. All right. If I do cosine times cosine, I get cosine squared. Now, that's awesome. 1 minus cosine squared. Don't forget the one we had way back a long time ago, and also the first slide on today's video. Remember, sine squared plus cosine squared is 1. If that's the case, think about this. Think about what 1 minus cosine squared is. It's sine squared. So what that is right there, anytime you see 1 minus cosine squared, you can replace it with sine squared. All right, so there it is. That's what I was trying to get. I was trying to get sine squared. Took 2 steps. Sometimes it takes 2 steps. Sometimes it takes, 22 steps. Okay, let's do one more. All right. 2 tangent x secant x equals 1 over 1 minus sine x minus 1 over 1 plus sine x. Wow. Okay, so when I see one like this, obviously go with the tougher side. So I'm going to go with the right-hand side and try to translate it into 2 tangent x secant x. So I see 2 fractions again. So I'm going to combine them into one fraction. So that's 1 minus sine x, 1 plus sine x on the bottom. Don't forget this. I'm basically cross multiplying right here. So 1 times 1 plus sine x is 1 plus sine x. If I go this way, now be careful here. That's really a negative 1. Okay, so negative 1 times 1 is negative 1. Negative 1 times negative sine x is positive sine x. All right, so what that gives me here is 2 sine x in my numerator. In my denominator, I have 1 minus sine squared. I just multiplied those two together. Those are conjugates. Remember, conjugates, you could just do foo when you multiply them together. All right, so 1 minus sine squared is cosine squared. So I'm going to have 2 sine x over cosine squared x. Now watch this. This is kind of a crazy trick. But when I get here, I'm going to go back and look what I'm trying to get to. I'm trying to get a 2 in the front, which I have a 2. I need a tangent and a secant. So what I'm going to do is I'm going to take this fraction that I have right now. I'm going to take the 2 out, and I'm going to put the sine x over one of the cosines. Notice I have cosine squared in my denominator, and I'm going to put another cosine x on the bottom right there. And the reason I did that is because think about what tangent x is. Tangent x is sine over cosine. What is secant? It's 1 over cosine. So I'm done now. I just have to write my answer. That's 2 tangent x, secant x. But you got to be careful of when you do these. You have to show every step. Okay, you can't just say, oh yeah, looks good. I think it's that side. You got to show every step. It's a proof. Didn't talk like that, but it's a proof. You're proving that the left-hand side and right-hand side are equal, so you got to show every step. All right, we're going to work on this a couple of days, so don't get frustrated. Don't look at the video and be like, oh my gosh. And even in class tomorrow, don't get, your key to the next 2 days is not to get frustrated. Just hang in there. Hang in there with me. All right, I'll see you in class tomorrow. See you, bye.